Okay, so let's just think back to the last lesson. And I want to ask you, what do you remember from the last lesson? What are some of the highlights? What are some of the key ideas that, when we study probability, we need to think about? So I'll put here the generic P of A, probability of A equals. What are some of the main ideas that are important for this section? It's kind of like our toolkit for the, and I really made a big deal about one particular thing in the last lesson. Feel free to turn your mic on if it's easier to audio, or put it in the chat. Whatever's easiest for you to communicate. What was the central idea of the last lesson? When we calculate probability, we need to know one particular equation. So what I remember is possible outcomes. And what was on top of that? So there was an equation where the bottom was possible outcomes. What was the top?
Hendrina has an answer for us.
Someone's hand. Whose hand is that? Hendrina, what do you think? What do you remember from the previous lesson?
I think the top is the number of outcomes that are favorable to A.
Perfect. Yes, favorable outcomes. So this is like the most important formula in the whole of probability. Is there anything else you remember from the last lesson? Okay, I think I might have lost you. So I was just thinking the probability scale. So the probability scale goes from 0 to 1, where 0 is impossible and 1 is certain. And then the other thing we spoke about is we use different techniques and tools to work out what the possible outcomes and the favorable outcomes are. And so the three main tools we cover are the Venn diagrams, the tree diagrams, and the table diagrams or tables. So those are the tools that we need to get better at. And then we briefly touched on stuff like this, but there's some vocabulary that's important. So there is something called complementary sets. So if sets are complementary, basically they fill the whole sample space and they are mutually exclusive. We also need to talk about vocabulary. I don't think we spoke about it, but what it means to be mutually exclusive. And then also some identities for probability. Does anybody remember any identities or things they want to share before we get going? Some important identities that we need to use in probability? Just kind of fishing for what you guys know and what you don't. Okay, I'll come back to the identities later on, but there's something called the OR identity, which is quite important. It says, what is the probability of A or B occurring? And so that's an identity that we need to be familiar with. And it comes up quite a lot in the context of Venn diagrams, which we're going to talk a little bit more about today. Aha, yeah. So Rachel, P, A, and B is also going to be involved in that identity. Yeah. Okay. Oh, and there was one other thing I didn't touch in the last lesson, which I must touch on, something called relative frequency. Relative frequency or experimental probability. So basically, when you do real world experimental probability, and it's when you do real world trials and you calculate probability based on these real world trials. Yes, so Rachel, you right, PA dash, that's got to do with the complements and words like, oh, you're remembering lots. There's also words like intersection and union, which stand for and or. So these are, you don't need to know all of these at the beginning, but these are some of the words and ideas that we're gonna come across as we go into today and later. Let's start with just a simple relative frequency question. This is experimental probability, and you use that main formula that I said was so important. So answer this question for me. If you spin a thumbtack 100 times and it lands up 38 times, what's the probability that it lands up? It's approximately what, based on this real world experiment? Which of these four options do you think is correct? So probability landing up. Well, there's 100 possible outcomes, and there are 38 favorable outcomes if the event is landing up. And so which answer is closest to 38 over 100? Okay, so yeah, it's going to round off to B. Okay, now one of the things that you may notice is that the theoretical probability given two choices is 50%. And so the experimental probability in the real world can differ from the theoretical probability. So just to let you know, you're not going crazy, because you may say, well, there's only two options here. Shouldn't it be 50%? But in the real world, experimental probability gets closer to theoretical as the number of trials get bigger. But if you run an experiment, you would just use the data that you're given. Does that make sense, everyone? Give me a thumbs up if you understand the difference between real world relative frequency and theoretical probability. Okay. The one is done in the real world, the one is done theoretically. And they do get closer if the number of trials get bigger. Okay, let us try and do this one. So you've got, you count the number of vowels on a page in a book. What is the relative frequency of the vowel A, or the experimental probability of the vowel A? Just want to get some. So how many possible outcomes are there? So I would add up all of these ones to say these are all the possible vowels. So the number of possible outcomes in total you definitely need. So I get 600. Now, what are the favorable outcomes for this particular question? It's asking us about the event of the vowel A occurring. And the vowel A is this. So 126 out of the 600 times. And so whatever that is, 126 divided by 600. 0.21, which would be C. Yeah. So yeah, if you get a question like that, it's awesome. You just use that same fundamental formula that runs through the whole of probability. Okay, so let's move on from that, because I think that seems like that went quite well. So I'm not going to stress too much. Okay, so let's talk about this thing called Venn diagrams. So a Venn diagram is a way of visualizing various sets or various events, and it's very helpful in understanding the relationship between different members of those sets. And some members can be in multiple sets, some can be in only one, and there's also a relationship to a probability calculation. So let's start with this question. It says you've given the sets A and B, and you've given them in set notation. Your sample space for this question, the all possible outcomes are the numbers 1 to 9. I want you to try and fill out this Venn diagram, putting the numbers in the correct place according to the definition of the sets and the events over here. I'm assuming some basic familiarity with the Venn diagram. See if you can figure out where you would put each number in the sample space. The sample space S is the whole thing. So it's the rectangle. And within the sample space, there are events A and B, and you need to figure out where each of these elements of the set go, or each of the individual outcomes of the set. And then once you're done, just let me know in the chat. So I'll give you a little hint. I look for the items that are in common to both, or in A and in B. And in the set A and B, we seem to have the items 1, 3, 5, 7. So 1, 3, 5, 7. Now, what about the other elements? We haven't used them all. The sample space S was all the elements 1 to 9. So we still have to put more items in our drawing. So what is going to go in B over here? What's going to be there? It's going to be 9, yeah, because that's this 9 over here. And then I think by the same reasoning, then 2 should go over here. Okay, last bit of this question. What about this outer region? What happens if it's not in, the way I would say it is, which items are not in A or B? So the set would be A or B, and if it's not, it's called the complement. So which items are not in A or B? So we haven't used 8, and is 8 in either of these? No, so 8 must be here. And we also haven't used 4. So 4 must be here. Have we used up all the numbers now? 4, 6, 8. What are the last ones we haven't? There's one more that we haven't used. So 8, 4, 1, 2, 3, 4, 5. One more, and 6. Okay. So that is an example of the different elements that come from the sample space. And if you're in A and B and so on, there's different types of events that can happen. I want to ask you a next question. I want to know, what is the n of A and B? What is the n, the number in A and B? So using probability notation, what is the n of A and B? So the number of items that occur in A and B. Who wants to unmute themselves and give it a go here?
Anybody?
Okay. So when I say n, the n means the number of items that fall in the sets A and B. And I count 1, 2, 3, 4. Yeah. So there are 4 items in the n of A and B. The items are the numbers 1, 3, 5, and 7. What if I said to you, what is the n of S? What's that going to be? What's the n of S? Well, the S is the sample space, and there are 9 items. Okay. I like this. I like where we're going. So what if I said to you now, what is the probability of an item being in A, or what is the probability of A and B in this particular diagram? What is the probability of A and B?
Mr. S,
Yes.
can you please explain to Kiriboni how you got the 9 in B?
So 9 is, it's just, oh, how did I get the 9 in B? I think he means the 9 in the sample space. Kiribona, which one do you mean? The 9 items in the sample space, or the value 9 in the set B?
Oh, yeah.
Okay. So I think he means the 9. So there's 9 elements in this whole sample space. So when I'm working out the probability of A and B, oh, the n of S,
Yes,
yeah.
sample space.
So S, if you look at the very top here, in this question, the sample space are the numbers 1 to 9, which means the n of S, the size of the set, is 9 items big. Now, when you work out the probability of A and B occurring, what I was thinking is you could use that same formula from the very beginning, where you say, how many possible outcomes are there? There's 9. How many are there that are in A and B? And use that to help me. Yeah, so there are 4 in A. So the probability of, in this question, of being in A and B is 4 over 9. Okay, which if you put it into your calculator is going to be 0.4 recurring. Yeah. Are there any questions or comments? Because this is an important idea, and I'm going to ask one more question like this, just to really see if you can get the fundamental, because this is almost the language of Venn diagrams and probability. What if I asked you, what is the probability of A or B? Okay, Nadi, am I losing you a little bit? Where am I losing you, Nadi? So if you think about this question, when I say what is the probability of A or B, there's an equation, and I'm going to ask you, how many items are there in total? Like, how many possible outcomes are there in this drawing? And then how many possible outcomes are there that are in A or B? Does that help a little bit, Nadi, in terms of talking you through this question?
No, sir. I'm a bit lost on how you got the 4 over 9.
Okay, so if we go back to the previous question, A and B is the region I'm going to highlight now. Do you agree that this is the region A and B? The one I've just colored in?
Yes, sir.
How many items are there in A and B? Can you see 4 items? 1, 3, 5, and 7?
Yes.
So that's where the 4 comes from.
Oh, okay. Thank you.
And the 9 comes from that there's 9 possible outcomes in total. So like the numbers 1 to 9 are the possible outcomes. Does that make sense? A little bit. Okay. So using that same logic, what do we think when we say or is the same as union of the 2 sets. So or is going to be the region that comes into or is going to be this region. It can be in A or B or in both. So this, when I say A or B, I mean that region that I've just graffitied in green. So now if I ask you, what is the probability of landing in A or B in this sample space? It's still going to be 9 in total, but what is going to be the numerator? Okay, so it's going to be 6. Yeah, because there's 6 items. So, and that's, 2/3 or 0.666 recurring. Okay, cool. I feel like it's time to move on, but I just wanted to show you how the language, if we look at the language of probability, it's this equation, favorable over possible, and then it's this idea of getting to know what n means and working with sets, and then also knowing about the or and the and knowing that the or means basically the union together of the two sets, the and means the intersection. And then just to throw one more thing at you, or is sometimes given as a happy face and is given as an unhappy face. Let's try and do one like this. So I want you to draw a Venn diagram to illustrate this information. And the tip I'll give you is that when you draw it, start with the innermost part of the Venn diagram. So it said here 23 said they liked both items in this question. Let that 23 be your anchor. Okay, off we go. Let's draw this Venn diagram as best we can. And when you're done, just say done in the chat. Remember, I want all the regions, huh? So I know these are going to overlap because 23 said they liked both. And so I start by putting 23 here. And that tells me those people liked both types of movies. Now, the question is, how do I go from this 23 to get 80 in total for action? Or how do I get this? Or how do I even get that? I'll give you a moment to think about that. So I want you to have numbers for this one, and for this. So I think for action, I would just go 80 minus 23, because you've used 23 already, you've got to get the difference, which would be 57. And then C would be 55 minus 32. So 55 minus 23, which gives you 32. And now the only thing I have is, what is the last one going to be? What's this region outside here? Or what I would call, so I know there were 150 in total. How many have I got so far? Okay, so I guess I have to go 150 minus whatever I know. So it's 57, 23, 32. So you should get 38. Okay, now we've solved the Venn diagram. And so we know about the size of the different items in here. Let's see how well you've understood stuff today so far, though. Let's have a look here. If I say to you, what is the size of N or C? Another way of writing that would be A union C. What is the size of N? N just means the size or the number of items, and then A or C. What's that going to be? Be careful, this is or, hey? It's not and, it's or. So it can be the region that I'm looking at, or it can be here, or it's basically the union of these two sets here. So all I need to do is add 57 plus 23.
You can see what's happening there.
Proper.
So 112. Yeah. Perfect. If I said to you, what is the n of A and C, or the other way of writing that is to write it like this. What is the n of A and C? Write that down. So that's the number of items. This is like the number of people who like action and like comedy. So they like both. It's going to be 23. Okay. Okay, last question before the break. I want to now connect this to probability. So I'm going to say, if you choose a random person from this group of 150, what is the probability that they like neither action or comedy movies? So the way I would write that is neither A or B would be A or B with a dash, because that's the complement. So what is the probability that someone chosen at random from this, not A or B, sorry, it should be A or C. So what is the probability of A or C dash? Or in other words, what's the probability that like neither action or comedy? So we have that is a 38 over here. So it's a probability now we're asking. So there's a number of possible outcomes and a number of favorable outcomes. What's that going to be? So it's going to be 150 on the bottom, and then whatever this one over here is, so that is 38. And so it's going to be 38 over 150. So the probability of somebody, if you chose a random person from this group, the probability that they like neither action or comedy would be 0.253 and so on. All right. I've been throwing it at you guys because you are like the sort of standard class, but I think it's time for a break now. We've done a lot of work. So I want you to turn your camera on and join me in a joyous stretch. Let's
Come
do
on,
this.
guys. Please
Turn
put
those
your cameras
cameras
on. Let's see your lovely
Shine
faces.
brightly, everyone. Shine brightly. Let me see those
You
happy
deserve
faces.
it after all that hard work.
Oh, just swing those arms for a bit.
Shout out to
Come on.
Rachel.
You know you want. Ah.
Shout
This,
out to
guys, it's
Amashe.
changing
Come
my
on,
life.
guys.
Missing out. You should be getting FOMO if you're not stretching now. This is like
Definitely.
you're missing out. Oh, goodness gracious. Okay. How are you feeling? Seth, are you stretching? Wizzy, are you stretching? How's it going?
I think they're camera shy today.
On. It's your time to shine. Okay, let us. Are you sure you had a stretch, guys? I'm going to give you like 10 more seconds just to reward yourself with a nice long stretch.
Come on, guys. Last chance.
All right, the brain break for today. Here is your brain break. I add 5 to 9 and get 2. The answer is correct, but how? Who has any ideas? Okay, I'll give you a tip. You hang it on the wall. I see some people 1 plus 4, 2 digit. Okay, so I'll give you that hint. Aha, yes, Mizzy, you have got it. Barbara, you've got it. So if I start at 9 o'clock and I add 5, I'm going to get to 2. And so that is the brain break for today. Cool. I hope you enjoyed that. And just make sure that if you haven't stood up yet, if you haven't had a stretch, please, your body is begging you, please give me a stretch so that my brain can work properly. Okay, let's go.
I think we have a question from Hendrina.
Hendrina, let's go to you. Yeah. Hendrina, what's your question?
Oh,
No, sir, it was a mistake. I raised my hand on accident.
No problem. Okay, cool. Let us do this question. I want to know A, B, C, or D. So there's 150 students is the sample space. That's the amount of students. What's the probability they choose to study Spanish? So a couple of answers have come in. Who else? So I know that 150 is going to be the possibles, and the favorable outcomes for choosing Spanish is going to be 20 plus 33, which is 53, which is C. Okay. I like what I've seen so far. Let me remix this question so that it gets a bit more exciting. What is, I'm going to use the symbol F for French and S for Spanish. So I want to know now, and this is based on this question, what is the probability of somebody studying French or Spanish in this group? There's 2 ways of writing it. I could write it like this, or I could write it like that. What is the probability? What's the correct answer for that question? I'll give you some time to think about that and pop your answers in the chat. So still going to be 150, but F or S, what's that going to be? Well, F or S could be this, this, and this. So 60 plus 23 plus 30. So 113 over 150. So that is the probability that the person studies either French or Spanish or both. Guys, are there any questions or comments about this? Because I'm going to keep asking quick little questions because it's such good practice. But if there are questions, please do let us know in the chat or raise your hand. Okay, what about this? What is the probability of somebody not studying French in this particular diagram? What's the probability that they're not studying French? So this is a little bit more sneaky. So one of the things we haven't looked at is, are there any people who don't study French or Spanish? And what I'm going to say is that to work that out, I'm going to go 150 minus all the regions that I have. So 150 minus that. So I get 37 for that region. But now the question is asking, what's the probability that I don't study French? It's basically the complement of French, and that region is going to be everything outside of French. So it's going to be essentially, it's going to be the region I've just colored in green. And how many items are there in that one? Well, in the green, there's the 30 who study Spanish and don't study French, and there's 37 who study nothing. And so my answer should be 67 over 150. And yeah, so there's that. So give me a thumbs up if you understand how I got that. Give me a thumbs down if you don't. That's what we call the complementary set. Okay. And just to show you something interesting, what is the probability of somebody studying French in this particular, what's the probability of somebody studying French in this particular group? So it's not just 83, it's 83 over 150. Yeah. Now, what do you notice about if you add the probability of F dash and the probability of F? So what do you notice if you... So if you take this number, what do you notice if you add those two together? No, you equal to 1. Yeah. And that's the complementary event identity. Sometimes we write it with the 1 minus on the one side, but you can see that that identity will always be true in general. Sorry, one like that. Okay, I think I've been hammering you with notation. We're making good progress. So let us, are there any questions or things you're curious about? Because as we've been doing this, sometimes questions will come up, and I want to give a chance for you to ask your questions or make comments. Mabantle, let's go to you. What's your question, Mabantle?
How did you get 67?
How did I get 67? Let's have a look. Which part of the question? Oh, for F dash.
Yes.
So if you think of the set F, which is French, everything that's not in that is colored green. Can you see my green coloring in? So I counted the 30 people over here and the 37 over here to get my 67 over here. Does that make sense? Because those people don't speak French. 30 of them speak Spanish, but they don't speak French, and 37 don't speak anything or don't study anything. Does that help, Mabantle?
Yes, sir.
Perfect. Okay. So let me move on. Let's just quickly check this question, these two multiple choice identities. Let me see if you come across this type of question. If two events S and T are mutually exclusive, then what is true about them? They're using the smiley faces and unsmiley faces, but mutually exclusive events would look like this. I'll give you a hint. So that's in a Venn diagram. That's what a mutually exclusive event looks like. An example would be if you've got like a dice and evens and odds are mutually exclusive. So you're correct. For mutually exclusive events, we say that they are the empty intersection. So the answer would be C, S and T equals 0. Basically, there's no common elements. If you get an odd number on a dice, you can't also get an even number. If you're in the one event, you can't be in the other. And so this is the common mutually exclusive identity that you need to be aware of. Then the other identity, which is going to come up more in future lessons, is the OR identity. And this is true in general, but it's normally, when it talks about in general, they're normally talking about a situation like that. So let's call that C and D. Which of these four options is the identity that is true that we need to know about in probability, and we'll come back to in future lessons to understand more deeply. Now, I haven't covered this today. I'm just checking with you guys kind of your general knowledge here. So in terms of this identity, the correct answer is D. And the reason it's D is that if you think about the region, so C or D is this whole region over here. And how do we get that region? Well, if we use this formula, if we add C, and then we add, so if we add the probability of C, it's basically going to be this region. And if we add the probability of D, it's this whole region. What you notice is we've double counted this region here, the intersection. We've counted it twice. That's why we have to subtract the intersection or the AND of C and D in order for this identity to be true. Again, I'd rather come back to that at a later stage, but just to show you why it works. If you add C and D, you've counted the middle twice. That's why you need to subtract the AND bit. All right. Thumbs up if you understand what I mean. Thumbs down if you're like, what is this man talking about? And I suspect some of you may be in the second camp. Okay. So you will see this identity coming up from time to time. I'm going to point it out again in the next lesson, but when you have the OR statement, so C or D, it's going to be equal to the probability of the one event plus the probability of the other event minus the probability of C and D. And the reason that happens is because the OR region, if you had to just add these two bits, if you just added these two bits to get the OR region, you've double counted the middle bit. You've counted some elements twice. That's why you need a subtraction for that middle bit. In the case where things are mutually exclusive and C and D don't overlap, this part would be 0, and we can just ignore it because there's no overlap. And that's the connection between the two identities. But I will come back to it in a later stage. For today, it's a little bit too much in one day. I just want to kind of get your brains going and thinking about it. Let's finish with a more realistic question for now. Or almost finished. I want to know how many students play football in this scenario. A, B, C, or D. We're down to our last bit of the lesson now. We've done well though, hey? Like we've made good progress in your Venn diagram notation,
You've
solving
done
for
very well.
and all that stuff. It's a lot of language, and next week you'll be really thankful that you've downloaded it now. So we have 15 students who play football and hockey. So there must be some students who do both. So my Venn diagrams are going to overlap. I've got football and hockey, and I'm going to put 15 over here. So then 18 students play hockey, which means this must be 3. Yeah. Now, how does this statement, each student plays hockey, football, or both, what does that mean? I think that means that nobody does nothing. So basically there's a 0 out here. Nobody does nothing. So then what is football going to be? What is football going to be? So I think it's just going to be 25 minus 15 minus 3, because there's 25 in total. And so then what will my answer be then? So I think it's going to be 7, because I know that in this region, there must be 25, because I know there's 25 students in total, but nobody does nothing. If I've got 18 so far, this must be 7, which is A. Oh, there's my... Let's do one more before I let you guys go. Before I do this one more, are there questions or comments about this? So I'm going to give an opportunity for questions before we go on to that last question. Let's try and do this one. So the two events are French and German. And there are students who study both. So since there are students who do both, I'm going to put the 11 in first. Now, I've dealt with this. I'm going to cross it out. 5 do not study a foreign language. So I guess that 5 would be out here. I know, I agree. This is tense. 14 students who study French. I guess that would mean this is 3. And 24 study German, which means if that's 24 in total, this must be 24 minus 11. So 24 minus 11. 13. And so then the final one would be add up all these, which is 5 plus 3 plus 11 plus 13, which gives me 32, which is C. Aha, that is looking good. Guys, I lied to you. I want to ask you one more question. I can't resist. I have to have this question. What is the probability of someone speaking or studying French and German? That is the final question. That's it. What is the probability of someone studying French and German from this particular class? It's going to be 11 because that's the number of items that are in both, and the total was 32. So it is 11 out of 32, or the decimal equivalent. Well
Awesome,
done.
guys.
Wow. That was really good. Yeah, you guys did really well.